Good morning, students. Today I'm going to explain what about the PSW in microcontroller. Myself, Prakyadi, working as assistant professor in the Department of Electrical and Electronics Engineering, SJB Institute of Technology. First, this is the problem is given. Before going to the exact problem, we need to understand what about PSW. That is nothing but program status word. So here they given two number that has to be converted into binary. So converted number is there, two number, and added number is there. Then we need to say what is the status of PSW. So what exactly the status of PSW? It is mainly dependent on what is the overflow flag, parity flag, auxiliary carry flag. These are all dependent in PSW. So let me explain. The first thing is what about the PSW flag. So for that, I will move on to the what exactly the PSW flag. Okay. So here is the PSW flag. So I will move on to the okay. So this is our PSW flag bit. As we all know that you can see it here, it is having a carry flag, auxiliary carry flag, F0, that is nothing but general purpose bit, RS1 and RS0. This is a selector, register bank selector. OV is nothing but a overflow flag, and this is user defined, and this is parity flag. So here there is a 8-bit, so this is an 8-bit register. PSW is an 8-bit register. That is the first thing we need to know about this. Then what is this CY indicate? What exactly this CY indicate? So this CY indicate that this is the carry flag. Okay, so that is nothing but PSW.7. PSW.7 means this is the lower byte and this is the upper byte. So lower byte we call it as PSW.0 and upper byte we call it as PSW.7. So PSW.7 indicate carry flag. When it will set and when it will reset. See, the carry flag sets or resets based on carry or borrow generated during arithmetic or logical operations. So while doing the arithmetic and logical operation, whenever you got the carry flag on the last bit, okay, last bit of your addition or subtraction, so that we considered as carry flag is going to set. If it is reset, there is no carry from the 8th bit of your PSW or 8th bit of your addition instruction. So that we call it as a reset. So what do you mean by auxiliary carry flag? Auxiliary carry flag sets or resets based on the carry or borrow generated between lower and higher nipple of the byte. See, first 4 bit we call it as lower nipple, second 4 bit we call it as higher nipple. So whenever during the addition, whenever there is a carry generated from the 4th bit to the 5th bit, then this auxiliary carry is going to set. Then F0 is available to the user for general purpose. So basically we are going to give it as a 0. Then RS1. RS1 is PSW.4. So this is the bit PSW.4. 0, 1, 2, 3, 4. So this is the bit. So this is register bank selected bit 1. And RS not, that is PSW.3. So this is RS not. So that is also a register bank selector bit. As we all know that we have a 4 register bank, that is bank 0, bank 1, bank 2 and bank 3. By default, all the operations are going on bank 0. So if you want to change from bank 0 to other bank, so we need to go for the selectors. So that is the register bank selector. If it is 0 and 0, then we call it as a register bank 0. So generally it is 00 working under register bank 0. So if I convert to the 01, then it will become 1. That is nothing but register bank 1 is going to select. That is from address location 08H to 0FH. 00H to 07H, as we all know that is an by default selector of a register bank. So 10, if you give it here 10, then it will go for the register bank 2. So that ranges from 10H to 17H. Then 11, then that we call it as register bank 3, then that is from 18H to 1FH. Okay. Then overflow flag, that is nothing but PSW.2. So overflow flag means it is going to be the range, okay, from minimum range to the maximum range the operation is going to happen. Once it exceeds the maximum operation or minimum range, then we call it as a overflow flag, then it is going to set. Then we have PSW.1, that is nothing but this is not defined by anything, so that is user friendly bit. Then the parity flag. So set bar clear by hardware each instruction cycle to indicate an odd bar even number of ones. If it is after the addition or subtraction, the number of ones in your answer is odd value, then that is an odd priority. Okay, so 1, if you have, then we need to give that as 1. Then if it is 0, then that is an even parity. So even parity means the even number of ones in the answer, then that is 0. Odd number of ones in an answer after doing addition or subtraction or any arithmetic instructions, then we call it as 1. So based on this information, we are going to solve the problem. So this is the problem is given. So as we all know that with the help of binary addition, okay, binary addition, see 1 plus 1. So 1 plus 1 we call it as 0 and the carry generated is 1. Okay. So 1 plus 0 plus 0 is 1. Then 1 plus 0 is again it is 1. So 1 plus 1 is 0 and the carry generated is 1. Okay. So 1 plus 0 is again 1. 0 plus 1 is 1. So 1 plus 1 again it is 0. Then the carry is 1. So 1 plus 1 again it is 0 and the carry is 1. That carry we written here. So based on our whatever the PSW is there, with the help of that, we need to write what exactly the answer. Okay, 1, 2, 3, 7. Okay, so here, what exactly there in our bit here? You can look at here. Okay, so I will take this to the our bit. Okay, new slide and paste it here. Okay, once this bit, yes. See carry flag, auxiliary carry, F0, RS1, RS0, overflow, user defined, and parity flag. So as I told, even number of ones is there means in the answer apart from carry. So that we call it as 0. Then odd number of ones is there means odd number of ones, then we call it as 1. So here, if you are seeing here, how many number of ones in the answer include the this one carry also. So 1, 1, 1, 1, 1, 1, 2, 3, 4, 5. We have 5 number of ones means what about your parity flag? Parity flag will becomes 1. So here this this okay, this one will becomes 1. So I will write, see, this will become 1. Then this is 0 and this is not excluding any of the maximum value, and we are going to work it in the band 0 means 0 0, if not also user friendly. Then we need to check these two. Carry flag means whenever we got carry from higher nipple means that is eighth bit. If you got carry in the 8th bit, then we call it as 1. So in this problem we got carry from 8th bit onwards. Okay, so auxiliary carry is nothing but carry generated from lower nipple to the higher nipple means 4th bit to the 5th bit. In this problem, this also it is going to set. So carry flag is 1, auxiliary carry flag is 1, and parity flag is 1 for the given problem. So you can see it here. See, from the nipple means this is the fourth bit. From the fourth bit, the carry is generated. Okay, carry is generated. And the last bit also the carry is generated. So based on this, the carry flag is 1, auxiliary carry is 1, and 5 number of ones in the answer. So parity flag is also 1. Like this, you need to explain or you need to understand how this PSW going to work in your microcontroller. So thank you so much.